So, good afternoon, students. Good afternoon. Good afternoon, sir.
Good afternoon, sir.
Okay. So, after the last class, do you have any doubt? Anyone? Yes. No. So, what we have discussed in the last class? So, we have discussed about the first module, okay, that we have completed in the last class. That was about different mechanisms and all. Okay, there we have studied about classification of mechanism. What do you understand by mechanism, message inversion mechanism, etc. And different initial concepts like playing, pair, all those things of kinematic chain, mechanism, inversion of mechanism, like what is the degree of freedom of mechanism, how to find it out. Okay, so those things already we have discussed, and we have checked about different inversion of slider pin chain, curve mechanism, double slider pin chain, etc. We have also discussed about different like all terms coupling, universal join, etc. This kind of different joints which can be used to like connect or the driver as well as the driven stuff. Okay, in the under different situations. So those things already we have discussed. Different. Then we have discussed about different mechanism, straight line motion mechanism, engine indicators, etc., etc. Okay, so intermittent motion mechanism, all those things already we have discussed. So if you still have any doubt with respect to the first module, you can ask. Otherwise, today we'll be going for the next module. So, if you have any doubt from the first module, so all of you have understood the first module, right? Let me know. Please let me know your regarding your understanding of first module. Anything which you have not understood, I can repeat prior to going for the next module. We can repeat if you want to. Also, all of you already know how to find out degree of freedom of a given mechanism. Yes. So for finding out degree of freedom of a given mechanism, what are the steps involved? Who can tell me? Rishikesh? Yes,
Sir.
Rishikesh. Yes.
Yes, sir.
Yes. Go ahead.
Sir, I think first we have to identify the links, sir.
Okay, then what is the equation that we use for finding out the degree of freedom of a planar mechanism? Of a plane mechanism or planar mechanism?
Uh, Equation I don't remember, sir. I have to look one time, sir.
Okay, anyone else? Rehan, do you recall the equation that we use? The expression that we use for finding out DOR? Here, Mickey?
This is with
Okay.
three brackets.
3 whole into, yes, correct. Go on. 3 whole into n minus 1 minus, we eliminate the 2p1, that is the higher pair or lower pair, 2p1, that p1,
Lower pair and upper pair. The P1
correct,
lower
lower
pair,
pair minus p2. Okay, and minus p2.
P2 pair.
And if there is any redundancy, redundant degree of freedom, that also we limit minus fr. Okay, so using this formula, we find out the degree of freedom of the mechanism. Okay, planar mechanism. So in that case, this is basically valid for the lower pair mechanisms. Okay, so valid for means like P1 is for lower pair, then P2 if there is higher pair is there, then P2 also will be there. Okay, so you should be able to draw the configuration diagram, then find out and show the different links that is there. Okay, then P1 and P2 also is a requirement. So for finding out P1 and P2, basically we go for your method of science you can go for, or there are other methods also available like loop closure mechanism, etc. look to the equation, those things also you can find that. But in your level, this for most of the cases you'll be able to find out P1 and all, okay, by checking what kind of join it is there, binary, ternary, etc. Then utilizing the concept like binary join, it gives you to equivalent one single pair, one binary join. Then ternary join or any higher order join gives rise to that, suppose n links are joined at that particular connection, then n minus 1 is the equivalent pair, okay, that it gives rise to. So those things you have to utilize, okay. So now any more doubt, anyone, any question? If no, we'll move on. Seems no, so I assume that you have understood the first module and you'll be able to solve some problems from first module regarding finding out degree of freedom, your steering gear mechanism related problem, and your hook join or universal related problem, etc. So those things you should find. And now today we'll be going for one third module, that is about cam and follower. Okay, so right now for the timing we are skipping second module, which is basically about velocity and acceleration analysis of different mechanism. So why I am right now it is leaving, so that because if there is a later on, if we physically meet, then it will be easy for us to follow the things. Okay, so that because there we have to solve certain problems, etc. Basically, we'll be going for different graphical methods in that particular case, where if you follow it with me, okay, and whatever it show in the blackboard, etc. If you keep on following, because what I have observed most of the time in online mode, you just join and you keep on listening, but I don't know how much you follow and how much practice you do along with me. So that's why right now, for the time being, I am leaving that particular module. Okay, I'll when I'm planning to start that hard module, cam and follow that particular module. Okay, is that okay? Yes, sir.
Yes, sir.
Okay, so okay, so now in this particular module, we are basically going to interested about a particular type of mechanism, very useful type of mechanism, that is the cab and follower. So now, by this time in past module itself, we have discussed about this cab and follower. Okay, so we have used the words cab and follower, and similarly in one of the problem related to your degree of freedom, finding out the degree of freedom of the mechanism, there also we have seen some involvement of cabin puller. Apart from that, in the example of higher pair or pair also, there also we have utilized the words amateur. Now, what is this? What is this cab and, or you can say the cam and follower mechanism? Now, as the name itself suggests, basically there are two basic, you can say, basic words are there. Okay, one is the cam, the other one is the follower. So now this cam. So in that particular mechanism, that means we'll be having, okay, mainly two things. Okay, one we call as the cam, okay, and there is the follower, and there will be certain guide which is going to give you guidance to the motion of that particular follower. Okay, so now if we have to define it, then how we can define about cam? Now cam can be called as a rotating, or mostly it is rotating member, and sometimes it might be, depending on the configuration, it might be reciprocating. Okay, so it's a cam is a rotating mechanical element which provides either rotating, reciprocating, or oscillating kind of motion to another element, okay, to another element which is attached with it. Okay, and that other element which is attached with it and which gets the motion from the cam is known as follower. Okay, so from the name itself, follower, you can understand that it is following. Okay, it is following something, and actually what it is following, it is basically following the cam motion. Okay, motion from the cam, depending on what is the shape, size, and movement of the cam, depending on that, basically the motion from the cam is imparted to the follower. Okay, and follower gets a certain motion which is being given onto it via the cam. Okay, so now you might be wondering, so you have got so many other mechanisms that you already know about, like providing motion from one element to another element. You have heard about gears, you have heard about different pulley, belt pulleys, etc, etc, whereby actually or maybe you have also studied about that type of electric motor that also can give you certain motion, etc. Okay, so now you have got other mechanisms. So okay, now you might be wondering why actually this particular cam and follower, that is also now required, cam and follower. Okay, so now actually the thing is something like that. So whatever normal motion that you know, okay, motion of a particular, whatever different mechanism we have already studied in past module also, there thereby whatever is the output motion that you get, that is certain kind of a standardized kind of a motion. Okay, so it was not a kind of unique, or it's not a kind of tailored kind of motion, but it's a kind of standard motion that you have already. There, for example, suppose the reciprocating motion of the slide in the case of slider grip mechanism, okay, whatever due to the movement of that particular crank, okay, you are getting a particular motion, and that is what type of motion that we get in the slider. If the crank is moving, okay, what type of motion we are getting in this particular slider? We are getting a sliding motion along this particular direction. We have got the guide here. Okay, so now that is kind of mostly continuous motion that is. Apart from that, we have also discussed about the intermittent motion mechanism, whereby we have seen that some kind of intermittent also motion from the continuous motion we can provide. Now sometimes what may happen, so you might need a particular motion in a kind of timely fashion, okay, or maybe the output motion may be very standard, it's not a kind of standard motion, and it's a very complicated output motion which are generally difficult to obtain. So this kind of for generating complicated output motions, which might be in a kind of from the time domain also, it may be time dependent. Suppose at this particular time I should have this kind of motion, after that suppose this kind of motion, etc., etc. So depending on the requirement, so complicated output motion which are not otherwise easily possible, okay, those are made possible by means of this particular cam and follower mechanism. That's why this use of this cam and follower mechanism we'll see in so many applications, right from the very, even from the some toys where you can give certain movement, from the toys to itself the big engines, okay, in the crankshaft of the engine, etc., to generate to have the particular piston movement, timely piston movement, okay, or regulation of the different valves that is there in the IC engine, etc., etc. So they will see the application. So now some application that we can discuss is like in the different automatic machine, cam and follower actually is used. So depending on the different closing or opening of different or different actuations, those are performed by the proper design and proper placing of that particular to the particular cam and follower. Okay. Similarly, in the IC engines for operating the different opening and closing valves, they are also use the cam and follower mechanism. In different machine tools also, we see the application of cam and follower. Okay. Now, up to this much, is it clear? That means what is this cam and follower that we are talking about, or why basically that is required? Are you following me?
Yes.
Okay. Now, as you're saying, like if you consider the IC engine valve operation, okay. So all of you know what to understand by IC engine. What is the meaning of IC engine? IC means internal combustion engine. Okay. So in your thermodynamics also you have studied. If we talk about the four-stroke engine, okay. So all of you have heard about four-stroke engine. Yes, four-stroke, two-stroke. These engines all of you have heard, right?
Yes,
From your thermodynamics also you know. So what are those four strokes? Can you anyone tell me? Can anyone tell me the four strokes that is there? What are the different strokes? Okay, that is there in a four stroke engine. I change. Who can tell me? What are the name of those
sir.
strokes?
Four
Hmm?
separate strokes, sir.
Yeah, what are those?
Compression.
Hey, you'll start with compression,
No, sir. Intake, sir.
intake, or suction. Okay, suction, then
Compression, sir.
yes, suction, compression,
So
then
combustion,
yes,
And exhaust, sir.
combustion and
so
exhaust.
intake,
Okay, yeah, intake is suction. Okay, intake or suction, same thing. Okay, Integral suction, compression, then combustion, or the working stroke, right? That itself is known as the power stroke or working stroke, right? And exhaust. Yes. So these are the 4 strokes. Okay. Now, can anyone tell me what basically happens here in these 4 strokes? Just in layman terms. Okay, whatever you understand. In take suction, what happens? Compression, in compression, what happens? In combustion, what happens? And in exhaust, what happens? Anyone?
The fuel goes in the cylinder in the suction, I think so.
Then in compression,
Since it compresses the fuel, sir.
basically the air and fuel mixture. Okay,
Yes, sir.
so the mixture is correct. Then combustion, it gets ignites. Okay, ignited and it just gives you the power. Okay, in exhaust,
Sir,
what
for
happens?
petrol engine, sir, we give spark, no, sir.
Yeah, we give spark. Correct.
But for
That combustion
diesel engine,
happens.
sir,
Yes.
sir,
That is
but
compression
for
ignition and spark ignition. That is different. That is the metal level. How you generate the ignition. Okay, compression ignition, CI engine or SI engine. Okay, we call it CI or SI. Okay, that is different. So those things you will be studying in your thermodynamics as well as in your automobile engineering exam. Okay, but right now I am just asking about this. Okay, so that I can show you how basically this is applied in IC engine operating of the valves in IC engine. I'm saying now we are saying the cabin follower application of the very vital application is there. Okay, so now if you look at this particular animation, okay, so if you see here, what you can see basically you can see a particular blue portion, this one. Okay, and if you look closely, this is not a, and this is the, you can say, shaft on which it is mounted. Okay, let's consider this is the black portion is nothing but the shaft on which it is mounted, and you can see this blue portion. Okay, dark blue portion. Okay, which is rotating there, right? So if you look properly closely, it has got certain shape like this. Okay, it is not a circular one, and this is the center position, so which basically this shaft is there. Okay, shaft is mounted here, and you can see there is this particular element. Okay, which is getting a particular motion to up and down kind of motion. Okay, and that is in connect, it is in contact with the surface of the your this particular blue dark blue portion. So now this dark blue is nothing but actually this is the cam. Okay, this is the cam portion. This portion which is getting the movement from the cam is actually, this is the follower. Okay, so it is following or it is getting the motion from the cam. Now how basically it is getting the motion here? If you look closely, so what basically happens? So now I believe I can eliminate these things. I can erase, right? Okay, so now after this much, is it okay?
Yes, sir.
Yes, sir.
Okay.
yes, sir.
So now how basically so this is what this blue is. This is cam. Okay, and this portion is follower, which is getting the this particular motion, and this element is actually in connection with it. Okay, connection means it is in surface contact with it. Okay, you can see actually there is this contact that is there. Okay, in between the cam and the follower, and in actual case there will be another element that will be there. Actually will be providing some guide for the movement of this particular follower. Okay, sometimes we can provide the guide, sometimes there will be like you have already studied about different types of motion. Okay, what is this different types of constant motion already you have studied. Depending on the type of constraint, some constraint will be applied, and so that this this gets this particular element, that is the follower, gets the proper motion that is required. Now basically how it is getting that particular motion. Now if you have properly seen, then you might have seen that basically the shape of this particular cam that we are showing is kind of oval shape, okay, or X shape. Okay, so here this is the portion, this is the center of the cam through which basically the shaft is mounted. So in this particular view, this is very evident. Okay, so you can very easily see. So this is the axis, okay, shaft axis. Okay, and that means in this particular case, this is okay. So now through which this is now the cam is given, suppose, and that this particular shaft is rotating. Okay, so allowing this particular shaft as the cam is keyed to it by the help of certain key. So along with that particular shaft, so what will happen? Your this particular cam also is rotating, right? Yes, because that is being keyed here. Okay, so now what happens? See, whenever it rotates, this particular cam, whenever it is rotating, if you think of a complete revolution, then right now this is the cam. We are right now not talking about the follower. Okay, the follower, what happens basically, it is in contact with the cam. Okay, and there is certain guide that we provide here for the movement of this particular follower. Okay, so let's consider this is the follower that it is there. Okay, and the contact is there. Okay, now that is one element over which another element is there. Okay, and it is in contact. Now what will happen if it rotates? Okay, if the cam rotates, now let's consider this is first position of the cam. Then after some time, depending on whatever is the angular motion, okay, it will assume this position. Maybe sometimes it will be assuming this particular position. Okay, and there will be a time when it will be assuming this particular position. Okay, let's consider this might be another look. Okay, and there will be time when it will move up to suppose this. Okay, this will be the position. Okay, similarly there will be time when it will be like this. Now if we consider that whole 360-degree movement, and after that once again it will move in this particular direction. Okay, and this will be like this. Okay, so up to this much all of you are with me, all of you are following me. Yes or no? Let me know.
Yes, sir.
Yes, sir.
Okay, thank you. So now, if you think of now this how this is cam is moving, that is okay. Okay, now we know that this follower is in contact with this particular cam. Okay, now think of that particular follower which is in contact with this. Okay, so what will happen? So when this is moving in this particular direction, at this initially suppose it is here. After some time, it has suppose reached to this position, and at the end, it has reached to the lowermost position, that is this particular position. Okay, so now in that particular case, what will happen? So this depending on whatever is the look or whatever is the design of this particular or the profile or the design or the profile, we call it as the profile. Okay, that look is we call it as a profile, cam profile. Okay, whatever is the profile of that cam, depending on that, what will happen? So a particular type of motion will be obtained on this particular follower. Okay, now in this particular case, what will happen? Initially suppose it was here, after that after some time, okay, at the end, okay, the position of the cam will be something like this at this end. Okay, and it will reach this position. During that time, what will happen? The follower will fall down up to this position. The contact will be there, but follower will fall down up to this. Similarly, after that continuously the cam is rotating, and it will assume this particular position, the uppermost position. Okay, so in that particular case, what will happen? That is this particular position we are talking about. Okay, this one. Okay, so in that case, what will happen? It has reached up to this much. Okay, it has gone down up to this much, and now it will move up along with the remain making the contact. Okay, contact already there up to this much. Okay, that means initially it was here, then it will fall to this one, and okay, once again whenever it is continuously rotating, the contact is there, contact is not broken, it will again move up. So ultimately this motion is translated to this particular element known as the follower, and follower will get this kind of motion. That means this reciprocating rotational motion of the Cam is basically converted to this reciprocating motion of the follower. Now you might be thinking, up to this much is it okay? How the motion is given. So similarly, we can see here the same thing has been shown here. So during this particular motion, actually depending on which part of the cam is in coming in contact with the follower position is remaining stationary, but it can have it is constant to move in this particular direction. Okay, so now depending on that, which particular portion, whether it is the round portion, this portion, or whether this is the this deep portion that is coming in contact with the follower. So depending on that, follower is sometimes this particular follower is sometimes moving down, then it is coming up. Okay, up to this much is it okay? All of you have understood how it is working? Let me know.
Yes, sir.
Okay, so for others also, I hope you have, all of you have understood. Okay, so now this, okay, those who okay, so now this type of motion wherever I require, okay, so that can be obtained as the output here. That means input I am giving in the cam can be the input, okay, and in the follower I am getting the output. So I am getting the output in the follower motion is the output motion, input motion is generally the cam motion. Okay, cam is the input and follower I get the output. That means depending on whatever is the type of motion that you need on a particular element, so that particular element will be attached to that particular follower. Okay, the follower will be getting that particular motion. The motion from the follower can be obtained, or directly sometimes the follower can act like the final element which is getting the motion, or the motion of the follower can be also transferred to another element which will be in connection with that particular follower. Okay, thus whatever is the type of motion that is required, complicated type of output motion, so that we get in that particular follower. So now you, as we are each and every time we are saying that's complete that person. Now you might be wondering, so if it's kind of only you can see like you can like some rotational motion, from the rotational motion we are getting the reciprocating motion of the follower. You might be thinking we could have done this using maybe the slider crank mechanism, where also rotational motion of that crank is converted to the reciprocating motion of the follower. Is it not? Isn't it? Some of you might be wondering. So now for them, I am saying, so basically our interest is in the different complicated output motion that I can get. So now sometimes what happens, some time requirement of that particular motion might be there. Let's consider, as I'm saying, IC engine valve operation. Okay, so there we know that the four stroke engine, if we talk about, then we know about the different strokes that is there, right? So four stroke suction, compression, and power stroke, that is the combustion and exhaust. So in that case, in the suction, what should happen? Okay, so what should happen in the suction stroke? So now we know that
Piston maybe. Piston.
is what happened, piston to what?
Suction of the piston will move, sir. It will
Yeah,
get
definitely
the
the
motion.
piston is someone is I think not on mute, so it is echoing. Yeah. So now actually yes, once so there will definitely the movement of the piston definitely is there, but right now we are talking about the, I think Nilut will please be on mount so that otherwise the sound is echoing. Okay, thank you. So now in that particular case, what happens? So you know that. So is my screen visible now?
No, sir.
No, sir.
Just wait. Internet was down, so okay, I think now it should be visible. I think it should be visible now.
Yes, sir.
So now, okay, so the person is clear, right? Okay. So now what happens? Sometimes what might happen? So just like in the case of AC engine of valve operation. So now what happens in the suction stroke? What happens? So open intake valve should be open actually, right? So in the meantime, what will happen? The whatever is the surge, that is the suppose fuel, etc. Okay, air fuel mixer. It should enter inside the mixing chamber or combustion chamber, and after that all those during compression, what should happen to the valve? Should it be remain open or it should remain closed?
So once suction is there, then it will open. When compression is there, it will close.
So basic ideal situation is what? During intake or suction, the intake valve should be open or closed.
Intake valve open.
Yes, should open. Then only we should be able to include the surge inside. Okay. So after that, what happens? During the requirement is for certain amount of time, there is a limited time frame for which the intake valve should remain open, right? So that the total complete intake is possible. Okay. After that, it should remain closed. Okay, during the duration of suppose your compression as well as the power stroke. Okay, it should remain closed. After that, what happens? The operating of the exhaust will come. So in the exhaust stroke, basically, ideally the exhaust valve should open, and for some time throughout the exhaust stroke, it should remain open. So the requirement of the motion is something like that for a certain time. So this particular valve, intake valve, should open. It should remain open for some amount of time, and after that it should close, and it should remain closed for a certain particular duration of time, so that both the strokes could complete within that particular time. After that, what about the exhaust valve? Exhaust valve should open, and the requirement is it should remain open for a certain amount of time. Okay, so now if you think like that, now is it a difficult or complicated kind of output motion or not? Because you have to time it also properly. It should remain open for some terms. It should open at this particular time. It should remain open for some duration, this particular duration, that is a particular, not a random one, but a standard particular time. It should remain closed, okay, and both the valves should remain closed for a standard duration of time, within which the, depending on the type of motion, type of the engine, the both the stroke, that is the compression, and your power stroke should be open, should be over. Okay, after that exhaust valve should open, so that you can exhaust complete. Okay, and it should remain open for a certain amount of time. Yes, now if you think like that, it's a kind of somewhat complicated motion or not?
Not complicated, sir.
Yes, now it's a somewhat complicated type of. Okay, if you don't have a standard name for it, right? So now this kind of motion, complicated motion, time which is required, like in a kind of within this particular time it should happen. Okay, for this time this kind of motion should be there. Okay, so this kind of thing could be accomplished by this Cam and follower. Okay, so now question, can you tell me whether it's a kind of higher pair or lower pair mechanism in general?
Lower.
What kind of contact is there in this case?
Sir, this is uh,
So this
line contact, sir?
particular design, actually yes, correct, it's a line contact. So this particular type of follower, we call it as knife edge follower. We'll see what the different categories of follower. And okay, and let's consider this is the cam. So here, if you think in terms of 2D, so this is the point contact that is there. Okay, and now if you extend it to the 3D view, okay, so basically throughout the cam, basically throughout the thickness of it, so it is the contact is there, so it's a kind of line contact. Line contact makes it higher pair or lower pair?
Higher pair, sir.
Correct, so it makes it higher pair contact. Okay, so now similarly there is something like depending on what is the how many you can say operation you want to perform. Okay, how many different parts you want to control with the cabin follower, so you can have on a particular shaft you can have multiple cams of different design, depending on whatever is your requirement of that particular machine. Apart from that, you can also have, just like in this particular case, the same cam, okay, same design of cam. If you look at both the cams, so basically they are of same design, same profile, that means, but you can orient them or connect them in a different way. You can see this particular, if you consider this as the look, this to be somewhat the look of this particular cam. Okay, so now this particular portion, okay, this longer portion, okay, so the if you look at this orientation right now, for this it is in this oriented, okay, for this second cam, okay, it is oriented like that. Okay, so this way we can have on the, you might have heard the word camshaft. So this kind of shaft on which basically the cams are mounted are known as camshaft. And in this particular case, this and these two valves are acting like as if they are the followers. So they are getting the particular motion here, and you can see whenever there is constant radius of curvature. Okay, so if you think about the constant radius of curvature portion, so in that particular case there is no change in this particular radius throughout from here to here. Okay, so during that time, whenever the whatever is the element that is the follower will be in contact with that, so during this motion, this angular movement of this particular cam, okay, the radius, that length will be same. Okay, so during this constant motion there will not be any movement that you will get on that particular follower, as you can see it here. Okay, in this lower one, so you can see for some of the duration of the portion. Okay, whenever this portion from here to here, okay, whenever this portion of the cam is in contact with the follower, even though the cam is moving, the follower is not getting any motion. Okay, but continuously the follower is moving. But after that, whenever from this to this, okay, and basically during this time it is this portion is more evident. Okay, sharp decrease. Okay, so during that portion, you can see what is happening, it is getting that particular motion, and after that once again for the other duration of time it is remaining close. So this way you can think of the opening and closing of the valve in IC engine also. Let's consider this is one valve, this is another valve. So this is, if this condition is open close position, then this position we can consider like open position whenever it is going down. And what is happening here? It is right now remaining stationary. And now once it comes here, it will go down open. For that particular time it was open, after that stop. Okay, and this cyclic operation is going on. Okay, this is how we can use it. So some examples you can see here. So here we are showing a cam shaft, actual cam shaft, where you can see the different cams. Okay, this is this one, this one, this one, this one, this one. Okay, so here it is also oriented in some other direction. So on the same shaft, okay, so many cams are mounted, and these cams will individually operate some other different the followers. Okay, some different followers. Whenever this cam shaft will rotate, along with that whatever cams are mounted they will also rotate, and depending on where is the position of the particular follower, okay, the follower will get certain movement depending on the shape of that particular, basically it depends on the profile of that particular cam. Okay, along with at what velocity it is, the frequency of the motion will be governed by what is the angular movement of that particular cam shaft. Okay, so after this much I hope you have it's clear. So the operation of inlet and exhaust valve in IC engines is being shown here in this particular diagram. So here you can see, here you can see this and these two are the two cams. Okay, and this green portion we are saying these are as if they are the valves. Okay, and along with that we have got the rocker arm. So other portion does, they are actually from this follower, actually they are communicating the motion to this particular valves. Okay, so the valves are resting on this particular valve seat, and whenever it is at this they are sitting on this particular valve seat, then it is this valve is, let's consider closed, and whenever it moves up it is open. Okay, so these are the cam, these are the follower. Okay, and from our follower actually the motion of the follower is transmitted after this. Okay, this is also acting like the actual the output motion we are getting here. This is the output motion we are getting on this particular valves. Okay, these are the valves. Okay, now how it is operating, I believe all of you can understand. So depending on the different strokes, okay, so actually the timing bell, etc., all those things are there. Okay, now let's consider this is the case, that means it should open and close. Okay, now whenever it should open and when it should close, etc., depending on that we'll be we'll be designing the cam. Okay, depending on for how long we already know, suppose what is the engine speed. Okay, and for how long suppose it should remain open for the total intake to happen, and after that for how long duration it should remain closed for the other two strokes, and after that how when the other valve should operate, when it should open, and for how long it should remain open. Okay, all those things are known, and based on those known values basically we design the this cam, okay, the profile of the cam, that is the look of that particular cam, which is ultimately going to govern what type of motion, okay, what type of timely motion we are getting on the follower. Okay, so now which one is the input, which one is the output? Cam is the input or output? Cam is input or output? Where will you get it?
Input.
Okay, correct. Okay, cam the input, and in the follower we get the output portion. Okay, so follower, we get the output. Sometimes directly the follower can give you the output portion, it can be directly used there, okay, and sometimes just like here, okay, the follower can be coupled with some another element, which is where we need the final ultimate portion. Okay, now after this first, I hope it's clear to all of you how the cam and follower operates, what is the requirement of cam and follower, and where we get the input, where you get the output, etc. Yes. I hope it's a yes.
Yes, sir.
Yes.
Okay. Thank you. Okay. So now, if we have to suppose we have to draw that particular cabin folder, then in normal case we mostly consider the cab to be a kind of rotating member. Okay. Even though the reciprocation motion of the cam is also possible. Okay. So let's consider this is the sorry about my drawing in this laptop is difficult. Okay. So this is the okay. So cam rotating motion. Okay, and let's consider we are having this particular follower here. Okay, and what kind of motion it gets? It gets this particular reciprocal motion. Okay, so this is the guide within which. Okay. Now, if there is no kind of guidance to it, okay, or ultimately there is no constraint somewhere or the other. Here you can see, even though here directly not the guidance given, ultimately it is sturdy enough, and finally here it is able to move in this direction only, cannot fall like this. Okay, the person cannot fall like this. So now in normal case, so there are how many elements are there in a cam and follower mechanism? So we can consider cam to be one member, follower to be another member, and this is the fixed portion. Okay, so this guide or fixed element can be considered as another element. So in normal case, there are, if someone asks you to draw a cam and follower and find out the degree of freedom, then you should consider like that. Okay, so three, and you can consider like three cam follower, and that particular guide also is required. Okay, and whenever you'll be drawing this cam and follower, then don't forget to show the motion. Okay, so cam is able to exhibit this kind of motion, the follower will get this kind of motion here. Okay, around this one. So now there may be like different classification of cams. There are different classification of followers also. So most of the times you will see classification of cams mostly divided according to shape and how the follower is getting the movement, or maybe how the manner of constant of the follower. Okay, so now depending on the shape, okay, looking at that particular, what is the look of the particular shape, we have got radial or disc cam. Whatever we have been drawing till now also is known as radial cam or disc cam, also sometimes known as plate cam. Okay, radial cam, disc cam, also known as plate cam. Okay, we have got cylindrical cam, we have got end cam, we have got wedge and flat cam, we have the spiral cam, conjugate cam, etc., etc. Those are, all of these are based on look. Okay, based on the shape. Okay, how does it look? Now you can see so many varieties are there. Okay, so here basically the motion of shape of this particular, this is a radial or disc cam. Okay, so that's also radial or disc cam, can be considered as radial disc cam. Okay, now just can anyone tell me if it's a pure circle, okay, and the center of rotation is here. Okay, if the cam center is here right now, this is the center. Okay, about which the shaft is there, and this is getting the rotation. Now can you tell me if it's actually purely a circular one and center is somewhere here, then will it work like a cam, this particular circular portion? in that case it won't behave as a cam, because what will happen in that case, if I have a follower suppose here, okay, which is in contact with the cam, if then what will happen, if this is the center about which it is rotating, if this is the case, okay, then all the time it will keep on rotating, and throughout actually there will not be any lift and all, maximum lift or minimum lift, so everywhere the r is same, okay, this is r, this is r, just like the same, okay. So in that case it will just keep on rotating here, and whatever is the element that is there, it will also remain there only, okay, just there will be kind of friction, okay, and apart from that there is no motion, okay, because there is no change in that. So that's why if it is just a circle, then it will not work. But if it will work if you provide some eccentricity to it, okay. That means if it is eccentric, okay, that means the center is not here, the center is not here but somewhere here, then what will happen, where there will be a time when if you think of the rotation of this particular thing, okay, and this is the where this is the maximum lift position, okay, and this much is the minimum lift position, okay. Now that means there will be a time when they should look something like this, when it has rotated, okay. There will be a point when it will be something like this, okay. Yes or no, all of you are getting my point? If it is rotated like this, it will get inverted. That means. Yes or no? Then what will happen? Previously, whatever was here, it will come down to this. Okay. After that, once again, when it the next revolution that is there, okay, once again it will assume this particular direction, and once again it will come to this, okay. That means then it will get the motion, okay, minimum lift at the maximum lift. Similar is the case, we can have different shape of cam, okay, and apart from that we can also have different motion that is given to that particular follower also. Here you can see if this follower is like this, so it is getting some oscillating kind of motion, okay. So it's not like always each and every time cam will be rotating and follower will be getting similar kind of motion, it's not like that. So there will be different versions of it, okay. So similarly here you can see this one is a reciprocating type of cam, okay. It is moving like this, and due to the shape, ultimately this is the profile of that particular cam, right? So ultimately due to this shape, this is getting this, okay. Whenever there is same, it is at here only, then there will not be any motion. After that it is gradually going down, and during this no motion, gradually going up, like that, okay. So mostly cam is rotating, but sometimes it may be reciprocating member also. And similarly, some all depending on what is the type of motion that you need, so many different shapes are possible, okay. So in the for today we'll stop here. The next class we will see the different classification of these different cams, okay, and followers, and depending on like its shape, size, etc, okay. Shape and motion, okay, not size. So with this we'll stop here for today. If you have any question you can ask. We'll stop. I hope you have understood.
Yes, sir.
Yes, sir. Okay. So if there is no question, we'll take the attendance. Nilutpal?
Present, sir.
Sankar?
Yes, sir.
Harsishman? Harsishman? Absent? Rehan?
Present, sir.
Partho? Partho? Absent? Rishikesh?
Present, sir.
Hermiki?
Present, sir.
Hermiki?
Present, sir.
Yes, Hermiki, okay.
Present, sir.
Mahasol?
Present, sir.
Teza?
Present, sir.
Rishikesh not?
Yes, sir.
And Emil? Emil? Okay, absent. Okay, so with this we'll stop here for today. Thank you everyone for joining.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.